Hi guys, it's Mrs. Harmison. Hi guys, it's Mrs. Harmison with your Chemistry 3F Notes Part 2. In this section, we're going to pick up where we left off last time. Last time I taught you how to find the limiting reactant. We're going to talk about what you can do once you have found the limiting reactant. Really quickly though, let's review what you do to find the limiting reactant. First, you're going to start with a balanced equation. Second, you're going to pick a product. Third, you're going to convert both givens to moles of that product. And once you have converted to moles of that product, you will compare the two numbers, and whichever one is the smallest was produced by the limiting reactant. For the rest of this video, we are going to look at what we can do once we find the limiting reactant. These problems are all going to be problems that you will find on your OWL homework and quizzes. This first one is a conceptual question, and we're wanting to find the limiting reagent. Now, first of all, the word reagent in this case means exactly the same as reactant. So we have one P4 molecule that reacts with 6 F2 molecules. And what's going to happen is there's going to be a PF3 that takes one of these and 3 of those. Another PF3 takes this one and 3 of these. And then another PF3 takes this one and 3 of these. And then the final PF3 takes this one and 3 of these. So we have these 4 PF3 that have been formed, and the only thing left over is this one PF4. So because there's some of the PF4 left, that makes that the excess reactant, which means that the F2 has all run out, so the limiting reactant is the F2. The number of PF3 molecules formed is 4, and the number of blank atoms in excess, so we determined that the P4 molecule would be left over, that means it's an excess, is 1. There is one P4 molecule left. Okay, here's an example of a limiting reactants problem. So the first thing we have to do is write this into a chemical equation. So silicon tetrafluoride is SiF4. The tetra prefix stands for 4. And water is H2O. And then hydrofluoric acid. An acid is going to start with an H+. Hydro means there's no oxygen. The fluorine is F with a -1 charge, so we end up with HF. And silicon dioxide is SiO2. So I reminded you in the last video how to balance the equation, but once you do that, you should have a 2 here and a 4 here. And that gives you a balanced equation. You also are going to need to calculate the molar masses of each of these substances. So for example, for silicon tetrafluoride, you would take 28.09, which is silicon's molar mass, plus 4 times 19, which is fluorine's molar mass, to get 104.09 grams per mole. Okay, so I've calculated each of the molar masses for the compounds. And a reminder, those molar masses are in the units of grams per mole. Now, the problem says, what is the maximum amount of hydrofluoric acid that can be formed? So we are trying to find the grams of hydrofluoric acid. It gives us two givens, 14.7 grams of silicon tetrafluoride and 3.49 grams of water. Now, to do any of these problems, the very first thing we're going to need to do is find a limiting reactant. And to do that, you pick a product. We are going to pick hydrofluoric acid because that's the one it's asking us to find. So we are going to convert both of these to moles of hydrofluoric acid. So first we've got to get away from grams. The grams of silicon tetrafluoride are 104.09. And then we need to get from moles of silicon tetrafluoride to moles of hydrofluoric acid. There are 1 mole of silicon tetrafluoride for every 4 moles of hydrofluoric acid. We get 0.5649 moles of hydrofluoric acid. Now, we don't know if that's limiting yet or not because we have to find the other one. So now we're going to go from our other given to moles of hydrofluoric acid. So we have grams of water here, so we have to put grams of water down here, and that's equal to 1 mole. And then 2 moles of water are equal to 4 moles of hydrofluoric acid. And when we type that all in, we get 0.3873 moles of hydrofluoric acid. Now, we have our two numbers now that we're going to compare. This number is bigger, so we are going to cross it out. We will not be using it for anything. We can't make that much. And this is the biggest number of moles of hydrofluoric acid that can be produced. And so we'll bring our arrow back over here and find that water is the limiting reactant. So it says, what is the formula for the limiting reagent? Again, that word is just like reactant. So we put in H2O as our formula for the limiting reactant. Now, the first question says, what is the maximum amount of hydrofluoric acid that can be formed, and asks for grams. So we have to convert this number to grams. So we're going to say 1 mole of HF is equal to 20.01 grams of hydrofluoric acid, and we will take 0.3873 times 20.01, and we will get 7.751 grams of HF is how much we could produce. So that's our second answer. Now our third question here says, what amount of the excess reactant remains after the reaction is complete? Now, we determined that the water was the limiting reactant, and that makes the silicon tetrafluoride the excess. So we want to find out how much of this are we going to have left over after the reaction goes to completion. And to do that, we first have to find out how much of this was used. Now, the reason we put this cloud around this number is because we're going to use this as our given for all the other things that we do once we find the limiting reactant. So we're going to start with 0.3873 moles of hydrofluoric acid. And from there, we can convert to any number of moles of any of these things. Right now, we're specifically concerned about how many moles of silicon tetrafluoride that we have used in the reaction because that's the excess. So we're going to convert from moles of hydrofluoric acid, which is 4 because of this number, to moles of silicon tetrafluoride, there's 1. And then we want to go ahead and go to grams because that's how we're going to get our answer for how much of the excess is left. So 1 mole of silicon tetrafluoride is equal to 104.09 grams, and we end up with 10.079 grams of silicon tetrafluoride. Now this is not our answer. This is how much is used in the reaction. So when all of this 7.75 grams of hydrofluoric acid is produced, it takes 10.079 grams of the silicon tetrafluoride to make it. But what we have to do is figure out how much is left. So we started with 14.7 grams of silicon tetrafluoride. So we're going to take 14.7 grams minus how much we used, 10.079 grams, and we are going to get an answer of 4.62 grams of the silicon tetrafluoride is used.